So I've got this buddy right now, and we're both kids of the 80s, and we're both really into synthesizers, but he's really into synthesizers right now. He's got, or he used to have this little one called the OP1, and this thing is awesome for just like fiddling around. It's really easy just to make some really fun, awesome music. But the other day, he sent me a picture of another synthesizer that he saw, and it looked like this. And that, well, first off, that looks awesome. I want to play with that, but I don't think I know how to make it make any sound. I don't know how to do anything. There's like 100 knobs, and there's like cables just sort of like strewn randomly about. And I would have, like looking at this, I have no idea where to start. And this, I think, is a really good example of what OTP looked like to me when I was first looking at it. I knew there was a lot of power there. I knew it could do some cool stuff, but I just had no idea how to do any of it. So let's just do some quick overview. What is OTP anyway? Well, there's a lot to it, but basically a collection of libraries and the hierarchy of supervisors and workers. That's sort of when someone says, hey, you need to learn OTP, that's generally like what they're talking about. There's, so the main OTP libraries are Supervisor and GenServer, and if you're using Elixir, there's Agent and Task, which are like abstractions of GenServer. But there's a whole lot of other components to OTP. There's application, there's GenStage, Dialyzer, ETS, the list just keeps going on. And this is not a complete list. There's so many different tools and aspects to OTP that when you're a beginner like I was, it's kind of overwhelming. It's hard to know where to start. But in general, when people are saying you need to learn OTP, they're talking about Supervisor and GenServer. So to learn Supervisor and GenServer, we got to start at the basics, and that's with processes. And this isn't like an operating system process. Processes in Elixir and Erlang are super lightweight. You can just spin up like 1,000 on your laptop and not break a sweat. So let's go ahead and see what that looks like. So we're going to jump into IEX, which is the REPL for Elixir, basically like your playground to try out code. So first we'll call spawn, and that's going to spin up a process, and then we're giving it a function for what to do. So we're saying, okay, spin up this process, and once you start process, I want you to run this function that's io.puts, and then hello EEF17. So the process starts up, and then prints out hello EEF17. And then we have this orange thing here. This, if you haven't seen it before, it's kind of weird looking, the hashtag PID with some numbers. And that's your process ID, or commonly just called a PID. And basically, that's how we're going to track this process. So we didn't capture it. So let's go ahead and just spin up the process again. And this time, we'll capture the process ID in the variable PID. So we'll run it up. It prints out hello EEF17. And now we've got that process ID captured in the PID. So let's go take a look at what our process is doing. So we'll do process.alive just to make sure it's still alive, and it is not alive. What happened to our process? So when you spin up a process, it runs the function you give it, and then it immediately just gracefully dies. And that's just how the processes work. You give it the work to do, it does it, and then it's done. So this is great. So now we know how to do processes. We're going to start throwing them in our application. But at some point, you're going to give a process a lot of work, and halfway through, it's just going to crash, and it's not going to die gracefully. So how do we deal with that? So we're going to do some error handling here. As I'm sure many of you have heard in the world of Erlang and Elixir, commonly said is let it crash. Like that's just the solution to everything. And when I first heard it, I was like, I don't want my application to crash. I don't understand how this is going to solve things. And part of that was the way I was thinking about applications. But when you think like outside of apps that you write, you think about like Photoshop. I'm a designer, so Photoshop is something that I often have issues with, or just your whole operating system in general, or maybe your video game console, your phone, some of my kids' electronic toys, your TV. A problem happens with that, and what's one way that's going to fix it most of the time for all of those? Does anyone here watch the IT crowd? Yeah. Have you tried turning it off and on again? And this works. It works like universally for computing and electronics. Like 90% of the time, this actually does fix the problem. Why? Why does that work? So the reason that works is because you're starting over that device or that app or whatever it is with brand new state. What happened somewhere along the way, that thing that had the issue got corrupted state. Something weird happened, and then it crashed, and then it had some issues, but restarting it, you're giving it fresh state, and you don't have that problem anymore. So the supervision tree is based on this principle. Because the way apps work in Elixir and Erlang is you have these clusters of all these different processes. We can try turning it off and on again at a very specific level. So we don't have to let the whole app crash. We're just saying that little piece that's not working right now because the state got corrupted or whatever, we're going to let that crash. So, so in this tree, basic tree we have right here, we've got some supervisors and then we have some workers. And supervisors are just other processes that have really, really simple job because you don't want them to crash. So all they do is they start up the processes, the children processes underneath them, or when they see the state go bad and the process crashes, they restart it. And restart isn't quite the right term because they're actually starting a brand new process that has the same starting state. So if you look at this tree right here, the worker down there on the bottom right, if that crashes, the supervisor right above it is watching and says, oh, hey, that just crashed. I need to restart that. And it'll try it a few times. And then if that doesn't work, it's going to crash itself. And then the supervisor above it will try restarting it. And it can kind of cascade all the way up. If your top supervisor crashes, well, then maybe you just need to rewrite because you got a really serious problem. But that's sort of the basic idea of the supervision tree. And when I learned this, I was like, okay, that sounds great. Like, that seems cool, seems useful. But what if that worker down there, what if I'm just a bad coder? What if I just have bad code in there? How is this going to magically fix my bad code that's just going to fail every time you restart it? And the answer is, it's not. That code is not going to magically get fixed by OTP. So if it doesn't fix that, what is it doing? So this is a part that took me a long time to figure out. But there's this really great article by Fred Hebert called The Zen of Erlang, and he goes over this. He identifies bugs as being of one of 4 types. So you've got your core features in your app and your secondary features. And then of those kind of bugs, you have the ones that are easily repeatable and the ones that are transient. So the first off, our core feature that's easy to repeat. It's pretty easy to find those bugs. Like those are like, oh, you do this, you do that, and you do this on this main feature of our app, this bug happens. So those are pretty easy to find. Secondary features also pretty easy to find, but often you overlook them because they're like, oh, I forgot our app even did that. That's a feature we made 2 years ago, and we forgot users actually use it. So sometimes those are the ones that you can overlook. But the transient bugs, these are the ones where you get the bug report, and you're looking at it, and you're like, I cannot get our app to do this. How did they do this? It does not make any sense. And these are the ones that are really hard to find because there's some crazy sequence of steps that somebody went through to cause the state to get into this weird state where this bug shows up. And so because of this, the kind of bugs that happen in production, the core feature ones that are repeatable, those should never happen. They do, but they shouldn't ever happen. The secondary features, those ones happen pretty commonly. That's often because you forgot about a feature and you're like, oh, that's a thing. I'll fix it real quick and we'll push to production this afternoon. The ones on the right, though, the transient bugs, those happen all the time in production because they're hard to detect. They're hard to find. The great thing, though, bugs that are handled by restarts, not really the repeatable ones, but the transient bugs, restarting that part of the app fixes that problem. So we have these kinds of bugs that are hard to find and hard to detect before they get to production, but restarting usually is a way to fix that bug. So we talked about all these just independent little processes, and they're memory independent, which is great. So restarting them doesn't affect any of the other processes in your app. But they have to have a way to communicate, and the way they communicate is with messages. So every process has the PID we looked at earlier, the process ID, which is like the mailing address for that process. And they also all come with a mailbox. So they are ready. When you spawn it up, it's ready to receive messages. We have to tell it what to do with the messages, but at start, it's ready to receive those messages. Excuse me. So let's go ahead and see how this works. So I'm a big fan of fantasy football, and it's never too early to get started for the next season. So we're going to build a real basic little app here that just lets us store the players in our team with some basic stats. And this past summer, when I was doing some learning of Elixir, I created a quick API wrapper for the Fantasy Football Nerd API. And so that's going to let us just feed a player name, and then it'll return back a bunch of data about that player. So the first thing we need to figure out for our new fantasy team app is how we're going to store the state. So there's a lot of different ways you can do it. If you're from Ruby, you're like, all right, time to build the database, because that's kind of how you do it. And there's nothing wrong with that. We can do that. If we go to production with this app, maybe we're going to build some database using Ecto, or maybe we could use ETS for more long-term storage. There's Nija. There's some other options. But for now, we're just doing kind of our own little app for us. So we're just going to store that state in the process, and that'll be fine. So this here is this is our basic process that's going to let us add players to our team, remove them, and store them, and return the full team. So let's go ahead and walk through this. So we've defined the module at the top, fantasyteam.basic, because we're just doing our basic process here. And then we have the start function. So this is the one that's going to kick up the process. And there we have the spawn process we did earlier. Instead of giving it a direct function, we're actually giving it a set of instructions. So first we're going to give it the module to call, and we do _module here, which just references the name of the module you're in, which in this case is fantasyteam.basic. So when you compile this, it's just going to replace that with fantasyteam.basic. And then, that's the module. And then the second one is an atom, and this is actually telling it which function to run under that module. And then the third is a list of arguments. In this case, we only have one argument, which is just an empty map. And so basically what we're doing is we're spawning up the process, and we're saying, hey, take that module and that function and these arguments, and then run that. So when the process starts up, it's going to run basically fantasyteam.basic.loop with an empty map as a function. And that's our starting state, because our team to start with there's no players. It's just an empty map, ready to receive data. So now we'll go down and check out that loop function we're telling it to run. So we've got loop state. So at the beginning, state is just the empty map. And then we have this receive do block. So before we had our process that immediately died when it finished printing out hello EEF17. In this case, it's actually going to sit and wait to receive a message. So at this point, it's just sitting there. It's not like eating up memory. It's not like blocking or whatever, but it's just sitting there waiting, not doing anything until it receives a message. So the first kind of message we want to be able to send it is this tuple that starts with an atom, and then the name. And the name will be a string like Russell Wilson in quotes. So we'll take that name, and then we will run, and this is a function we have in the background that does the API that calls up the data. So we're going to take that name, Russell Wilson, and we're going to run fantasyteam.player.find Russell Wilson, and that's going to return for us this big map with a bunch of details about that player. So, like college Wisconsin, team Seattle, position quarterback, etc. So now we have this player variable that's got a map of all that information about the player we just added. And then we're going to define a variable called new state, and this we're taking the existing state, which is an empty map, and then we're adding the key of Russell Wilson, and then all of his information as the value for that. So now we're going to have a map that has one item in it, which is Russell Wilson, and then all of his stats. And if we just stopped right here, it would create that state, and then it would just die, so we would lose it because we haven't looped it again. So here's where we have recursion. So after we define what the new state is, we're going to run the loop at the top again. We're going to run this function again, but now our state, instead of being an empty map, it's the map with Russell Wilson. And so now that we run loop, we're back at the top, and now we're waiting to receive another message. So the second kind of message we have listed is remove a player. And it's the same thing. It's the remove atom at the beginning of the tuple, and then the name that we're trying to remove. And then we don't need to check the API or anything, because we're just removing the player. So we define the new state as the existing state minus this player that we want to remove. And then we loop it again back up at the top. And then our third message that we're going to receive is an atom with team and then the PID. Because when you're calling this, you need a message back. You're asking for, send me back the team. So when you send this message, you're sending like yourself. The process sending this message is sending its own process ID so that this process that we're spawning up knows where to send the message to. So like if we were in IEX and we sent a message to this, it would send its own process ID with the message so that our process we're defining right here could send the message back to IEX. And then we do that with the first thing here. We just do send to that sending PID and then send it the state. And then we're not changing the state at all, so we're just going to loop back up at the top with that existing state. And that's it. So this is our basic process module. Let's go ahead and see this in action real quick. So we'll jump over to IEX, and we're starting up fantasyteam.basic.start and capturing that PID so we can send it some messages. And first we're going to send it the message, the tuple, add the name Russell Wilson. So then we see the return, like there's the message being sent, add Russell Wilson. And now we're going to do it again. We're going to add Doug Baldwin, and then we'll actually try out just to make sure it works. We'll remove Doug Baldwin, and then we'll send the message for the team. So we didn't it sent off the message, you see right there, team, and then our process ID, but we didn't actually get anything back. And that's because IEX isn't built to do anything with that message. So the message was sent, but it didn't do anything with it. And so we can just flush out the mailbox and then see, oh, there it is. There's our map with Russell Wilson and his details. So it did get the message. It just didn't have any way to handle it yet. So this right here, we just walked through. This is a really, really, really common pattern in Elixir and Erlang. And it's so common that they've built a generic library to emulate it, which is called GenServer. What we've done here, it's pretty easy to kind of walk through and understand, but it's actually missing lots of edge cases. There's a lot of issues. This looks nice and clean and simple, but there's a lot of issues with it having to do with compatibility with supervision trees, deadlocks, message ordering, tail call optimization, dynamic tracing, and I don't even understand what half of that is. But luckily, really smart people do understand what all that is, and they've been working on GenServer for 20 or 30 years behind the scenes. So it has a lot of history behind it, making sure it's battle tested and taking care of all the edge cases I don't have here and do not understand. So let's go ahead and see what it looks like if we take what we built and move it into a GenServer. So might be a little hard to see in the back. We are going to zoom in. So on the left, it looks like it's about twice as much code, but half of that code is actually convenience functions. So we don't even, really the code that's doing most of the work is pretty much the same. There's not really that much more. So we're going to go ahead and go through this so that it all makes sense. So to start off, we do the line use GenServer, and that's like saying, yeah, we want to use all that great stuff that the OTP team has built. So we're going to go ahead and bring that in here. And that's going to let everything else work in this module. So we always start with the use GenServer, and then now we'll jump down to those functions at the end there, the ones that are similar. So, well, first we have our start function, so that's the one that kicks it off. And it does kind of the same as before. Before we had spawn with the process, spawning the process that had the module, the function, and the arguments over on the right. And on the left, now we just do GenServer.start, and we give it the module name, which again, that double underscore is just pulling the name we have at the top of the module. And then we don't actually need to give it the name of the function to run because it has its own loop function. We're not going to have to define how the loop function works. It kind of has that already. So we're just going to pass it an OK tuple here. And then the third list there, that's for options. We're not going to use any of those today. So now we'll jump back. So we have this init function. And this is something you do in every GenServer. When you do the first thing, GenServer start, that's going to start up the process. And it knows to look back at the module, because we defined that as the first argument. It's going to look back at the module and say, hey, I'm a GenServer. I need an init function. What is your init function? And so we define it right here. And all it is, we're just doing an OK tuple and then the second part of the tuple is the state. So there's our empty map. That's where we're going to define our state here. And then we're going to jump down to this function here called handlecast. So before, on the right, we had this big encompassing loop function that had the receive, do, and then all of our messages. So with GenServer, we don't have kind of a wrapping function, a wrapping loop function like we did over on the right. Now we're actually going to be able to handle each message individually, and GenServer is handling the looping in the background. So with this handlecast, we have the part handlecast is receiving the message, add name, like before we had under the receive block. Now we just have it as the first argument of handlecast. And then the second argument is the state, which instead of putting it up in the loop function, because we don't have that, we're going to define that as the second argument of every handlecast. And then we'll jump down to this part, and this is exactly the same. We're looking up the player in the Fantasy Football Nerd API, and we're defining it, and then we're creating the new state by adding that player to it. And now instead of running our loop function like we did on the right, because again, we don't have it here, we're just going to return a tuple that starts with no reply because we're not sending a message back to the calling process, and then the new state. And then GenServer knows how to now maintain the loop with this new state. So then we have our second one here, the handlecast with the remove function. It's pretty much the same thing. We've got the message received there as the first argument, and then the state. The state is the second argument, which is again is at the top of the loop on the right side. And now we have this line, which is the same thing. We're defining a new state, which is removing that one player from the existing state. And then we have a no reply tuple with that new state in it. So the third one, instead of handle cast, this is handle call. And the way GenServer works is it kind of has two types of messages that you can send it. You can send it a cast, which is kind of like sending a postcard. Like you're not expecting a reply. You're just like, hey, do this, and now I'm going to go ahead and do my own thing. Or you can send it a call, and that's where you're asking for a return. You're like, hey, do this thing, and then tell me when you're done. Like, I want to know what the result of this is. And so in this case, the result is I want to know what the team is. So I'm going to send the message that's just the Atom team, and then we also send the second argument there is from, and that's the sending process ID. And most of the time, you don't actually need this. There are some cases where you do, but we're just going to precede that with an underscore because we don't actually need that value. And then the third one is the state. So all we need to do here is return a three-element tuple that starts with the Atom reply. I've been doing too much Twitter thinking lately, I guess. And we have state in here twice. So the first one is that's actually the message that's going to be sent back. So before on the right, we did send to that process ID the state because that's what they want. They want to see the entire team. So here on the left, we've got the second argument there, which is the first state, and that's the message being sent back. And the second one is that's the state that we're going to save. So in this case, they're the same. But like if we had another handle call that was like quarterbacks, I just want to see all the quarterbacks that are on the team. The first one would be all the quarterbacks, and then the second one would be the full team because we still want the full team to be the state. Okay, now we'll jump back up to the top, and there's our convenience functions. So we have the start right at the top that we already went over. And then now we have our add, remove, and team functions. So first we've got add and remove, and they work pretty much the same. First you will list the process ID of this GenServer that we're starting up, and then the name like Russell Wilson. You want to add Russell Wilson or remove Russell Wilson. And we're going to take that, and then we're just going to do genserver.cast. And so what that's going to do is it's going to, when you run my fantasyteam.mygenserver.add process ID Russell Wilson, it's going to do GenServer cast, and it's going to cast a message to that process ID we gave it, and then send it the message, add name, and then remove name, and then those will be handled by the handle cast and the handle call that we went over already. And then with the team, we don't have to supply a name, so we're just supplying the PID. and it's going to do GenServer.call, and that's going to send the message and wait for the reply. Yeah. So there we have our full GenServer. And the one thing that's really kind of annoying with this setup, though, is we have to track that process ID. And that sucks. So we're going to get rid of that, because for this example, I'm just trying to track my own team. I'm only in one league, so I don't need to worry about a whole bunch of stuff. We're just going to make this real easy. So we're going to add a name to this module. Now we're going to call it single server. And so here we have a module attribute that just defines name as the module name. And then we're going to start plugging that into our convenience functions. So now when we do GenServer.start, before we didn't have any argument or any options on the right, so we just had an empty list. Now we're going to say, when this process starts, I want to give it this name of fantasyteam.singleserver. And why would we do that? Well, now we don't have to cast to a process ID. We don't have to keep track of that anymore because we know the name. So now in the GenServer.cast, we can just plug in the name right there. And the cool part about that is now we can take the PID out of our function name. So now it's just fantasyteam.singleserver.add Russell Wilson, and it knows what the GenServer is and knows the process ID, and we don't have to keep track of that. Because one of the most annoying things about all this is tracking process IDs. So anytime we can get rid of that, I'm going to do that. So there we go. So let's go ahead and see what we've built in action here. So we go ahead and start up that GenServer, fantasyteam.singleserver.start. We see the process ID right there, with GenServers, it returns, rather than just the process ID, it returns a tuple that starts with OK and then the process ID. But we don't need to capture it because it has its own name. So we can just, right from here, say fantasyteam.singleserver.add Russell Wilson, and it just returns like OK, which is like, sweet, OK, I guess it's working. We'll go ahead and do it again with adding Doug Baldwin, and then we'll remove Doug Baldwin, and then we'll go ahead and do our team call. And that gives us the return value of the team. So there we see it. So cool. One thing, if you're using Elixir, they've done this thing where they take GenServer, and GenServer kind of, what we've used it for is basically just storing state. Like, it's not doing any complicated stuff. It's just storing the state. So Elixir's kind of taken, the other thing you can do with GenServer is do a lot of kind of complex work and like concurrent tasks and stuff. And we're not doing any of that here, but Elixir's kind of taken abstractions from GenServer, and so it has agents which just do storing state, and then it has tasks which just do kind of all these concurrent work. So let's go ahead and just see what we've built already. We're going to see it as an agent real quick. And this is it. This is the full code that does everything our GenServer did, but now it's as an agent. So it's a lot less code because we have kind of those convenience functions where it's just myAgent.add, and then it runs everything from right there. So we have agent.update, and that's one, there's only kind of a few functions that agents do because all it's doing is storing state. So one of them is update. So when we do agent.update, we give it the name or the process ID if we're not using the name named server. And then we send it the function for how to update the state. So in this case, you're taking the state, and then you're saying map, put the new player into that state. And the same with remove, map, delete that player from the state. And that's all you need to be able to maintain state with an agent. Oh, yeah, there. Yeah. And then we have, for the team, we're just trying to get the current state, so we can use agent.get. And then our function is just like, hey, function state, yeah, the state, send us that back. There's a few other functions you can use, like instead of just update, you can say get and update. And that's going to, you're going to want to return a 2-element tuple. So the left one is the state you want to see first. And you can do other stuff with it right here. We're just returning it as the first element. And the second element is going to be the new state that we adjust here with the map by either adding the player or removing the player. And then there's also agent.cast. So all of the other ones, update, get an update, those are all calls. So you're actually, when you run agent.update, you're waiting for that response to, for like an OK tuple, or to find out, like, OK, yeah, it added the player. With the cast, you're just like, fire and forget. Like you're like, yep, go add the player and I'm going to do my own thing. I don't need to know that you did it. I trust that it's going to work out or whatever. Okay, so one thing, if you're more familiar with this, you might have been wondering like why I'm using start and spawn instead of start link and spawn link. And if you're not wondering that, then let me tell you why we should be using that. So when we had our supervision tree before, I talked about how a worker would crash and then the supervisor would see it crash and restart it. So the way that works is processes need to be linked together. So when you, instead of running spawn, if you run spawn link, that links it to the calling process. So if you're in IEX and you run spawn link, a process, and then that process crashes, IEX itself actually crashes too, because they're linked to each other. If one of them crashes, the other one goes down. The cool thing, IEX is already using the supervision tree, so you might not even notice, because IEX will go ahead and start right back up again, which is pretty awesome. So that's a really quick way to see a supervision tree in action, is just run a spawn link and do like the function, 1 divided by 0 or something. And it'll just kill it and restart IEX for you, which is pretty cool. But the problem with this, you don't want the supervisor to go down if one of its child processes go down. So supervisors have this thing that's called trapping the exits. And basically that's saying like, oh, it went down. I'm going to not crash myself. And instead, I'm just going to restart that process. So yeah, as I said before, we had some functions that are just start and they would spawn, or GenServer.start, agent.start. All we do is change those to adding the underscore link. So spawn underscore link or GenServer.start link. And then we would go ahead and change the actual starting function names to that too, which we don't, I guess, technically have to, but it's just a common pattern. You want to have that so that when you start it up, you know it's linked process. So we're doing pretty good here, but if our GenServer goes down, it's still just going to die because we don't have anything actually supervising it. So let's go ahead and do a supervisor real quick. And supervisors were really intimidating for me, but there's really not that much to it. They work, like I said before, they're really simple. All they're doing is starting processes or restarting them when they crash. So at the beginning, we just do this use supervisor, just like we did with GenServer, and that's kind of getting all the magic that the Erlang and OTP team have been working on for decades, which is pretty nice. Real easy, just like, oh yeah, one line. Let's use all that awesome stuff you guys have done. And then we're going to start up our supervisor with start link, and then that'll do supervisor.startLink, and we give it the module name that we're in, so fantasyteam.mySupervisor, which is at the top there. And then we have the options, and we're not going to use any options here, so it's just an empty list. And so that supervisor process is going to start up, and because it's using supervisor similar to GenServer, it's going to look back at our code at this module that we gave it and say, okay, where's your init function? Because that's what I need now that I've started. So we do our init function here, and we're just going to give it the empty list because it doesn't have any advanced options. And then we're going to define a variable called children, which is just a list of the processes that we want it to start up. In this case, we're just going to have it start up our single GenServer. So we give it a worker function, and we would do this for if we wanted it to start say 3 workers and 1 supervisor, we would just have 3 functions in here in this list and a supervisor function. But in our case, we're just having it start the 1 GenServer that we're going to watch. So we say worker, and then the first argument is the module name of the process we want it to watch, which is our single server, and then again, empty list for no options there. And then the thing that makes this all work, we end our init function with a supervise call. And so this is going to take our list of children, which is just our 1 server, and then it's going to give it a strategy. And so there's a few different strategies. Like your basic one is the 1-for-1. That means if you have a supervisor that has 4 processes underneath it, if one of them dies, it's just going to restart that one. There's some other ones like restarting all of them if one of them dies, and a few other ones. I think there's just 4, and they're pretty simple once you understand. Once you understand one of them, it's pretty logical to go down the list. But for this case, we just have the 1 process, so we're just going to do our strategy is 1-for-1. And that's it. So now instead of starting your GenServer with fantasyteam.singleserver.startLink, we would start with fantasyteam.mySupervisor.startLink, and then this will go ahead and start up our GenServer as well. And now it's being monitored and good to go. So quick recap. So we started with processes, and then we built a GenServer. We named that GenServer so we didn't have to track the process IDs, and then we built a supervisor to keep track of that GenServer so that if something goes wrong, it'll go ahead and restart it. If you're more advanced with OTP, you may see a few flaws in what we've done, because there's a lot to OTP, like I said before. And there's a lot more you can do to make what we've done work a lot better. But what I did teach you is this, and you can make some music. You can't do a lot with all of this, but you can do a little bit with this thing called OTP, enough to kind of make some stuff work. And now you can well, hey, what happens if I grab this cable from over here and plug it in? What else can I do? You have kind of that foundation to be able to start learning some of the other things from OTP. Like maybe you want to, well, I want to figure out how Erlang term storage works, ETS or ETS, whichever way you want to pronounce it. Now you have kind of a model to build off of to do that. Yeah, so that's it. You can follow me at Jesse J. Anderson, or Jesse J. Anderson, as all my friends call me, because it looks like that on Twitter. And I also created a quick link, a bit.ly link for ABCs-of-OTP. That's got a bunch of links to different books that have really helped me to understand OTP. Dave Thomas and Sasha Urich both have books that are great. One that really clicked for me was Benjamin Tanwehow. He has the little Elixir and OTP guidebook, and that was kind of the light bulb moment for me where it finally started to all make sense. There's also a new book that's just kind of came out in beta by Lance Halverson. I think he's here. And I read the first third of that book on the plane ride here, and it's fantastic. Highly recommend that one too. And that one's called Functional Web Development with Elixir, OTP, and Phoenix by Lance Halverson. So that's it. Thanks. Is there any questions? Any questions?
So when do we use agent and when do we use GenServer?
Right. So.
Just repeat the question.
Oh, yeah, sorry. The question was, when do you use agent and when do you use GenServer? So there's kind of differing views on this. Now that I really I feel like I understand OTP, at least the basics of it in GenServer, I like to always just use GenServer, because then if I need to change it later, I want to add some more difficult stuff to it that isn't just storing state, I have it. But agent's pretty nice. It's a tiny little amount of code. So if you know, this is never going to do anything more than just store state, agents are kind of a great way to go. But there's not a right or wrong answer. It's kind of personal preference. Yes?
So you talked about agents. You didn't talk about tasks. So what are tasks?
Right. So the question is about agents and tasks. And I talked about agents. I didn't talk about tasks. So tasks are, I haven't used them, so I'm not super familiar with it. But kind of the idea is, if you have some complex, maybe you're doing machine learning or something you have a bunch of complicated work you want to do, and you want it to run concurrently, so it's using kind of all the different processors in your machine or whatever. Tasks is kind of a great way to just send out and have it it automatically kind of can run that stuff really well. I don't actually use tasks, so I'm not super familiar with it. But that's kind of the idea. You have a lot of work you want to be done, and it's going to be done better if you have a lot of processes kind of doing pieces of the work. And tasks are really great for that. But I'm not familiar with a lot of usage of them. Yeah. Yes? Oh, perfect. There you go. If you want to talk to someone about tasks.
It's the same issue, though, with agents.
Yeah.
You write them. If you want to do anything more with it, you're just going to go to the
Right. It's really great, and then you're like, oh, now I got to make it a GenServer anyway. Maybe I could have just started there. Right. Yeah. Cool. Any other questions? Yes?
Is there unit testing or integration testing? What's the philosophy for Elixir and testing?
The questions about unit testing with Elixir. Yeah, there's some great testing. I don't know the knowledge off my head, but yes, there. XUnit, I think it's called.
XUnit.
Yeah.
Doc tests.
Yeah, and doc tests are awesome.
You can embed what you expect from a return from a function, and then you add that to your test suite, and that way your docs are unit tested. So
Yeah, so Elixir really encourages you to use documentation in your functions because you can do doc tests. So your documentation in your modules will have little examples of how to use that function, and doc tests will actually run those to make sure that they work, which is really, really cool. Yeah.
Or anyone that's read crappy documentation.
Yeah, it will force you to improve your documentation, or you'll have a lot of failed tests. Yes?
Yeah, with Elixir 1.4, with the introduction of the registry, like how does that kind of fit into like managing the PID and like naming processes? And
Right. So the question is about Elixir 1.4 and how it added this new thing called the registry. I don't know. I'm excited about it. I've heard good things about it for managing process IDs, but I'm not familiar with it. I'm excited to learn because managing that has definitely been one of the pain points for me in trying to do anything kind of more advanced. So, yeah. Question in the back?
In regards to the registry, I have a blog post on Medium about using that for managing the syntax scenarios. So
Awesome. I probably have that saved in Pocket, ready for me to read later. Any other questions? Yes?
What happens to the state of the server in case like it crashes? Right? Do you lose the state?
Right. So that's one of the things I talked about where someone more familiar with this was like, yeah, but you're losing the state if it crashes. And that what we went through, you would lose that state. And that's some of the stuff I refer to like ETS and Ninja and other ways that you can save that state in a more permanent place. Yes?
How does this help if the state that is causing the negative side effects, crashing,
Mm-hmm.
is saved in permanent storage, so it'll just get reloaded?
Right. So the question was about what if the state is bad in permanent storage and you're just sort of refreshing it with that bad state? Is that right? You have supervisors have like a limit, so they'll try to restart it a limited number of times, and you can adjust that. And if that fails, it'll kind of cascade up. If you have a really bad situation, you may need to get in there and fix it. Like if it's somehow the state got corrupted and you haven't like engineered a good way to clean that state, if that makes sense. So hopefully that's the sort of thing that you would be able to, that it would be caught before it went to like permanent storage, if that makes sense. Yeah. Anyone else? Awesome. If you have any other questions and you see me around, go ahead and ask. I'd love to chat. All right. Thanks.